Hey there, class. We're here today. We're going to take a look at something to do with components, and specifically, we're going to look at the idea of how to mathematically find a component. In some previous video, we looked at the idea of a component, what a component was, and really didn't worry too much about the mathematics of it. But today, what we're going to actually worry a little bit about is how to actually mathematically find a component. So let me get zoomed in here, and we're going to take a look at the example that we're going to look at here today. So I have two components, I have two vectors here. I have the vector A, which is 12 meters at 40 degrees north of east, and I also have the vector B, which is 14 meters, 20 degrees east of south. So the first thing I'm going to actually do here is I am going to draw in the components. Okay, so here they are. They're drawn in. And of course, we have the x component here along the x-axis. Okay, so there's the x component. And we have the y component right here along the y-axis. Now, to actually calculate these, what we're going to need to do is we're going to need to use some facts here. One fact is that these are at right angles. Okay, so we end up with a right triangle here. And when we have a right triangle, we can use things like Pythagorean theorem. We can use things like SOHCAHTOA, sines, cosines, and tangents. So what I'm going to redo here is I want to kind of understand that, first of all, I guess I should mark this in. This angle right here is my 40 degrees north of east. So the triangle that I want to look at, okay, I'm going to shade it in here. This is the triangle here that I'm going to kind of focus on. And for our purposes, so it doesn't get quite so messy, I'm going to just kind of redraw the triangle over here. And again, I'm not too worried about, if it's the scale or not. And basically, it's just kind of a rough idea. So my goal is to find this side right here. That is called the adjacent side. Of course, this is the hypotenuse. And this would be the opposite side. Again, given that we have this angle right here, which of course in our example, we actually do. So my goal is to find the adjacent side, which is going to be corresponding to the x component, and then the opposite side, which is going to correspond to this side over here, which of course will be equivalent to the y component of my vector. Okay, so just a quick reminder, we have this handy thing to remember the trigonometric ratios. They're SO, CA, and TOA. And what I'm going to be looking for is one that gives me the adjacent side, which is going to be the x component. Now, I also do know the hypotenuse. In our case, of course, this hypotenuse is actually equal to the 12 meters. We're trying to find this, and we're trying to find this right here. We, of course, have this angle here as well, and that's 40 degrees. Okay, so if I'm looking for the adjacent side, notice that SO does not even have the adjacent in it. So that I'm going to get rid of. CA, that's the cosine, is going to have the adjacent in it. So that looks like a pretty good candidate. It also has the hypotenuse in it, which is a good thing. So I think this is going to be where I want to start. So let's set up the ratio. Cosine of theta, in this case, again, it's 40 degrees, is equal to the adjacent over the hypotenuse. Again, if we substitute our values in, cosine of 40 degrees equals the adjacent, which is an unknown thing. We're going to call that, let's call it AX for the x component. And then the hypotenuse is the 12 meters. Okay, so my goal is to get the AX by itself. So I'm going to multiply by the 12 meters on this side. Of course, as with the way algebra works, I need to multiply on this side. Over here on the right-hand side, this 12 is going to get canceled out by that 12. That's a really wide highlighter. Let me use a red pen instead. These two cancel out, leave me with, of course, the AX on this side. And, oh boy, let me erase that real quick. There we go, it's gone. So we're going to be left with AX on this side, and then on this side, on the left-hand side, we're going to have 12 meters times the cosine of 40 degrees. I'm going to pause the video and I'm going to plug this into my calculator and we'll see what we get. Okay, so as I plugged this into my calculator, I ended up with 9.19 meters for the magnitude of this component right here. Now, of course, vector components are vectors in their own right. So if I want to write this as a component, as a vector, then I would want to also include its direction. So it'd be 9.19 meters at a direction of east. Okay, so if we want to fully define this vector component, it does need to be, in fact, defined as a vector. All right, now let's move on. Our next goal was to find the y component of this vector A. So notice here in my triangle, I have the hypotenuse. I now know the adjacent side, and my goal is to find the opposite side. So one thing I could do is I could use the Pythagorean theorem, because I know two sides of the triangle. The goal is to find the third side. So that would be one method. Now, I'm going to opt not to do that, and the reason for that is because to do that, I would be using this value here, and that value is a calculated value. I want to try to stay away from calculated values as much as possible because I've rounded them off, and that introduces rounding errors. So I'm going to try to stick to known information as best as possible. So let's take a look at our trig functions again. I notice here in my sine function that I would want to find the opposite. That's good, that's what I want. And I have the hypotenuse, so I think the sine function in this case would be the route that I would like to go. So let me move the screen over and we're going to put this together. So it's going to be sine theta equals the opposite side over the hypotenuse. Again, putting our numbers in, that's going to be sine of 40 degrees equals, we're going to call this AY, since it's the y component, and the hypotenuse was 12 meters. In a similar fashion to what we did before, we're going to have to multiply both sides by the 12 meters, so I would actually end up with 12 meters times the sine of 40 degrees, and that's going to equal the magnitude of the y component. When I put this into my calculator, I'm going to find that the magnitude is 7.71 meters. And as always, if I want to actually talk about the component here as a vector, which it truly is, then I would need to include its direction as well. So that's 7.71 meters at a direction of north. So the end result, if we're asked to find the components of this vector A, the components again are vectors, so the x component would be 9.19 meters east, and the y component is going to be 7.71 meters north. Now there was a second part to this example, and that was finding the components of the vector B. I'm not going to actually talk this through. I'm going to do this kind of as my video is paused, and I'll come back and show you the work here in just a bit. Okay, so here we are with the second vector. This is the vector B, and as you can see here, I've drawn my components. Here's my x component, here's my y component, and then the triangle I'm going to focus on is this triangle here, and it's simply because I know this angle here is 20 degrees. You can, of course, always, knowing that this is going to make a 9-degree angle, you can, of course, use the triangle in here. No difference. It's kind of a preference thing. Since this is the one I'm given, that's just what I'm going to do. So I'm going to go down here and show you my work. Again, one thing I guess I didn't emphasize earlier, but I like to kind of redraw because these pictures kind of get a little bit messy, especially when you're dealing with multiple forces. I like to draw what I'm going to call a helper triangle. Okay, this is not the vectors themselves. This is just the triangle that I've highlighted from above to kind of help me figure out what's the opposite side and the adjacent side and whatnot. So basically, what it comes down to here is the x component is, and I have these labeled wrong, I just noticed that. This should be b and that should be b. I'll fix that here in just a moment. There we go, it's fixed. It's like it never even happened. But at any rate, the opposite side here is going to be equivalent to the magnitude of the x component for b. So I've used the sine function here, and as you can do, I've done the algebra, isolated it, did the math, making sure I'm in degrees mode, by the way, in my calculator, and I end up with the x component is going to be 4.79 meters easterly, or in an easternward direction. And then my second one is the y component here. The y component is the adjacent to this 20-degree angle, so I'm going to use the cosine here. And again, I have it set up, solving for the y component, or my unknown variable here, and do the math, get 13.2 meters. And of course, with all vectors, we always need to define with both the magnitude and the direction. And in our picture here, we can see that that is in a southerly direction. So hopefully you can see here with this idea of components, it's kind of just adding one little layer of extra understanding to our sandwich of vectors. And hopefully here, using some things you already know about sines, cosines, and tangents, and you're able to now calculate the vector components.